Oh my goodness, look at that. Hi everybody. That was pretty terrible. Hi everybody. Thank you, very good, right on. All right, we don't have a lot of time. We have no time, we have very little time. So, first things first, we're hiring, if you wanted to, there's headcount, right? Do you know of any of the headcount? Which projects have headcount?
Not exactly.
Oh, well. Pivotal.io careers, that's one thing. Now, where are we? Did you change the slide?
No, that's okay.
Oh, yeah, right. Okay. So we're here. Hi, Sébastien.
Hey, so I'm Sébastien Deleuze. I work for Pivotal as a Spring framework committer, and I work on Webflux and all the Kotlin stuff, basically, in various Spring projects.
And my name is Josh Long. I'm a Spring developer advocate on the Spring team, and I'm open source engineer and contributor. And as I said before, we're going to go through a lot of stuff. We have a lot of stuff to go through. So keep in mind, first of all, this code is online. Where's the code going to be? Do you know?
It's already available on GitHub.
Okay, so you've got a Git repository for this talk?
Yeah.
Okay.
You go to the tutorial, you click on Go to Repo, and you have all the code you are going to show.
So that tutorial there, spring.io/guides/tutorials/spring-boot-kotlin, will guide you in all things Kotlin, and you should definitely read it after you're done with this talk, not now, later. If you have questions, comments, feedback, whatever, don't hesitate to reach out to us. As always, we're here to help you. So if you have feedback, don't hesitate to reach out to us. I'm always curious. Every time I come here, I'm always curious about, first of all, who's using Twitter? Twitter? All right. 2018. Twitter. All right. The rest of you, get on it. Great place to be. What? Facebook. No. GDPR day, man. That's the opposite of what you want. Twitter, use that. And then what about email? How many of you are using email? Just curious. Maybe. Yeah, it's not very healthy. Whatever. Moving on. So a little bit about myself. My name is Josh Long, as I said before. I'm an open source engineer and contributor. I am the lead contributor. The lead, and he can confirm this, number one contributor to projects like Spring Boot, Spring Cloud, Spring Integration, Spring Batch, VOD, and Time Leaf Activity. Number one, top ranked, most visible, most prolific, most highly acclaimed, most continuously contributing contributor of bugs. But still, number one, more bugs per any commit. And I'm also an open source author and engineer, and I just finished this book. This book is called Cloud Native Java, and this wasn't published this time last year, but it is now published. This book is called Cloud Native Java, and it's all about how to build applications that survive and thrive in the cloud using Spring Boot, Spring Cloud, and Cloud Foundry. And this book took we thought it would take 6 months, okay? We thought it would be just 6 months, very quick, in and out, no problem. We thought that given what we know about the technologies and our perspective of the ecosystem, that we would be able to deliver this book very quickly and get it out. But it did take a little bit longer than we'd expected. It took a little bit longer than we thought it was going to take. And, there's a lot of reasons for that, but it did take a little longer than we'd expected, okay? It took 2 years, all right? It took 2 years. It took 2 years longer than we expected. And again, a huge part of that is the deliberation, the back and forth, the very rancorous, the cantankerous, the arduous, the difficult discussions that we, the author team, Kenny Bastani and I, had with the publisher, the very, very intense deliberations over the animal on the cover. Now, anybody who knows anything about O'Reilly books knows that it doesn't matter what's in the book itself. What people care about, first and foremost, more than anything else, ultimately, is the animal on the cover. And we eventually settled upon a blue-eared kingfisher. A blue-eared kingfisher is, of course, a bird that is indigenous, or as we say in English, native to the Indonesian Java Islands. And it's a bird, and birds fly, yes, through the clouds. So it's a bird that is native to Java that flies through the clouds. It's a cloud-native Java bird. It's a bird. Never mind. It'll come. Okay. It's a good bird. It's a good bird. And I want to name it something, but we haven't really thought of a name. Maybe Springy or something like that, or Booty. All right. Anyway, we work at Pivotal, and at Pivotal we have a lot of good open source software. We care about open source software ultimately, but remind you, what we care about first and foremost is helping people build better software faster, as always. And I always mention this because it's very important. And as a huge part of that, of course, we do everything we can at the framework level and at the different languages, the different infrastructure levels to support that goal. But ultimately, there is a last mile, I think. There's a last mile that has to be addressed to really get the last bit of productivity out. And so today we have the pleasure of talking about Kotlin, right? So I guess that's that.
Yep.
So we're going to talk about Kotlin as a way to sort of close that last mile. How far can we get by squeezing extra productivity out of the language itself?
Okay. So we are going to see two parts in this talk. I will begin to create a blog application using regular Spring Boot 2, GPA, and Kotlin stack. And then Josh will show you more forward-looking stuff with all the reactive, DSL, things like that. So we are going to create a new project. And we are going to create directly that with the Spring Initializer wizard directly in ID. We are going to call it blog. I will make the screen bigger just later. We are going to use Gradle. And here you can see that I can directly select Kotlin. We have added Kotlin support in start.spring.io website and web services a few months ago. So you can directly create that. And then you select the various dependencies. So we are going to create Spring MVC application with a mustache template. And as I said, it will be a regular GPA application with H2 embedded database. And then that's all. I'm just creating that.
Now, H2 is an in-memory,
Yeah.
embedded SQL database. It's in memory and it's embedded. So that means that every single time you restart the application, it's going to lose all of your data. Every single time you restart, all of the data will be gone. In this way, it's very similar to MongoDB. You'll just lose your data all the time. All the time.
Yeah, good point. So here you can see that start.spring.io is creating a new Spring Boot project that already supports Kotlin. So this is a regular blog application file. You can find the same kind of annotation than in Java at Spring Boot application. Here, with an empty class, I don't have to put empty brackets in Kotlin. And a first difference is that in Kotlin, we have top-level functions. So instead of having the main method inside the class, I directly have a top-level function. And here you can see run application. It's a Kotlin function provided with Spring Boot 2. So Spring Boot 2 brings Kotlin support because it is based on Spring Framework 5 and also provides some dedicated Kotlin stuff. And run application is the equivalent of Spring application.run for Kotlin. You can use that also to customize. So, Josh, I'm going to do something horrible.
Okay.
I am going to disable the banner.
Ah.
Yeah.
Ah, you.
I know.
I thought we were friends.
That's horrible. So, you can use that to customize the application. That's not only a small shortcut for basic use case. You can also do advanced customization, like adding some initializer, disabling the banner, sorry, guy, and that kind of stuff. Another thing that we do for you is to pre-configure the build. So we support Maven and Gradle. Here I'm doing Gradle. And you can see that that's a fully working Kotlin and Spring Boot project where we specify the latest Kotlin version, Spring Boot version. We pre-configure all the plugins. So here we are in ID, so bye-bye Eclipse. We enable the Kotlin plugin. Kotlin Spring plugin is a special plugin because one of the differences between Java and Kotlin is that in Kotlin, classes and methods are final by default, and you have to use the open keyword to open them. And with CGLib proxies, that's not a good fit because we need to extend these classes at runtime. So we have worked with JetBrains to create a Kotlin Spring plugin, which will automatically open classes and beans annotated with Spring annotations. And that also works with meta annotation. That means if you have some custom meta annotated with Spring annotation, that will work as well. Two customization are done on the compiler level. So this is to be able to leverage Spring Framework 5 nullable annotations. With Spring Framework 5, we have annotated the whole Spring Framework code base to provide a full null-safe API. That means every parameter and return value on the Spring Framework code base is annotated with nullable or non-null, and that allow with this, this configuration Kotlin to have a full null safe API. In practice, that means no more null pointer exception. We know for sure if a parameter can be null or not. The last parameter, the last configuration is enabling Java 8 bytecode, because by default, Kotlin generates Java 6 bytecode, and here we want to generate that. So I'm going to add a new plugin in order to be able to deal with GPA, because one of the things that we are going to see is that with Kotlin, we are going to use data classes with a single constructor with all the parameters, and GPA per spec requires to have default constructor. So this plugin will automatically generate a synthetic default constructor to make GPA happy. We are going also to update Gradle to 4.7 because we are going to use JUnit 5. So why are we going to use JUnit 5? That's not only to use the latest stuff. It's to be able to do constructor parameter injection of the bins, which is only possible with JUnit 5, and also to use non-static at before all and at after all. So I'm going to enable JUnit 5 support. So I'm going to do that. Use JUnit platform, okay. And as of Gradle 4.6, it is supported by default. I am going to exclude JUnit 4, okay, because it is used by default in Spring Boot. And I am going to import JUnit 5 dependencies. The second step is to modify that. So I'm using extend with, and Spring Runner becomes Spring extensions. We are going also to import the JUnit 5 flavor of the test annotation. I'm removing the old imports and the unused one. And here you have fully functional JUnit 5. So it's supported by Spring Boot 2, but not the default. So I do this configuration to be able to support it. And we are going later that we are going to do a constructor parameter injection. And here, if you want to use before all and after all, with JUnit 4 and by default with JUnit 5, it needs to be static. So let me add that. It needs to be static methods because classes are test classes. Tests are instantiated one time per test, and here, so if I do that, that does not work. If I run the test, I will have a failure because by default tests are instantiated one time per test, and it don't support that. But if I want that to be supported, I will enable a new feature of JUnit 5, which is instantiating test one time per class. So to do that, I'm creating a new test repository, test resources directory. I'm going to create a JUnit platform .properties file, okay? And I am going to enable the per class lifecycle. And then, if I run my test, okay, so now it works. I am able to use, like with TestNG, I can use non-static before all and after all method. And we will see other advantages later. So we are fine with that. We are going to write our first Kotlin controller. So I am writing a new HTML controller. So I am not just long, so I will use live templates for my live coding. I'm cheating, but yeah. So here I'm creating a new controller, and you can see that here I'm going to import a Kotlin extension. So Spring Framework provides various Kotlin extensions that allow to add Kotlin-specific APIs to the existing Java API that we're using in Kotlin. And here, if I go to the source of the extension, you can see that extensions allow to add a new method. So here I'm adding a set operator to the model class, a regular Spring model class. That will be just an alias to this dot attributes. And that allow me to write this kind of array notations for the model instead of writing model.addAttribute, just a shorter thing. So I'm going to add templates. So I'm using mustache. So I'm going to add header.mustache. OK. That's a header. I'm going to add a footer. OK. Footer.mustache. OK. So the footer. And I'm going to add the main template for the blog. So blog.mustache. OK. And that's it. I'm rendering a title attribute. It is set here. And obviously, I'm going to write some tests because I'm going to write integration tests. OK. So here you can see the feature I was talking about. I'm directly injecting a constructor parameter with my test rest template bin instead of doing a field injection. So that's much better, especially in Kotlin, because that allows me to have non-nullable, immutable properties. So val is for immutable, var will be for mutable. So here I'm really able to use immutable, non-nullable things, even if the test, and that's much better.
For a second, I got confused there. I thought you were using Java 10.
No, Kotlin. I'm also using expressive test names. So I use that especially for tests. When I'm using backticks, I can use real sentences instead of just the camel case notation, and that allow me to have expressive test names for free.
Kind of like Spock.
Yeah,
and spec.
Yeah, totally. So now we are going to add persistence. So I'm going to create my model using Kotlin data classes. So Kotlin data classes are classes that are specifically designed for holding some data. So these data keywords allow to automatically generate equals, hashcode, function, and copy methods. And here you can see that I am using immutable properties and mostly non-nullable immutable properties with the val keyword. So by default, types are non-nullable in Kotlin, and when you have this question mark, that means this could be nullable. We have explicit null safety in Kotlin, and that's a big feature. I put optional parameter with default value. You see here, equals null and equals local.time now. That means that if I don't specify these parameters, Kotlin will automatically create set this default value. And usually, I put the optional parameter at the end. That's why the ID, which is usually at the beginning, is at the end, because this is an optional parameter that could be automatically set. And I put that at the end. That means I can only specify title, headline, content, and author. And ID and added at will be automatically populated if I don't specify them. I'm going to create the repositories. So it's not unusual, repositories. It's not unusual in Kotlin to group various classes and interfaces into the same file because code tend to be shorter. So that's not unusual. So that's just regular Spring Data repositories. And then I'm going to write additional tests. So here I'm not writing integration tests, repositories tests. I'm going to test only the repository slice. Okay? So here you can see that I'm still using JUnit 5 tests. I'm using addData GPA tests. I'm auto-wiring all I need, and then I create some sample data, and I just check that it's working. Let's check everything is green. Okay. It will be your turn, Josh.
No problem.
I'm going to implement for now the real blog engine. So I'm going to write a more complete implementation of that. So So in this new version, I'm using implicit auto-wiring. So as of Spring Framework 4.3, when you have a single constructor on a class, it will be automatically auto-wired. I don't have to use @auto-wired explicitly. So here, I'm leveraging that feature and the fact that Spring Framework recognizes Kotlin classes to automatically auto-wire repositories and the converter. And really, in Kotlin, even more than in Java, constructor-based injection should be the default. And try to use only that, because that's a very good fit with Kotlin null safety support as well. You see we are missing a converter, so we are going to create it. So markdown converter. Okay, so markdown the converter is using the common mark library. So the converter will compile markdown to HTML. Okay, so we are using a library for that. We are wrapping that into a bin. And here you can see that in Java, I would have implemented function of string, but in Kotlin, you don't have to use functional interfaces. You can use that, and there is conversion between, there is some conversion, but you can use directly function types. When I say function types, this is types only defined by their lambda signature. So here, markdown converter is implementing a function that will take as input parameter a nullable string and will return a string which will be the compiled HTML code. So, okay, now we have the markdown converter, but there is still an error. You see that I'm trying to call a format method from local datetime with no parameter, and that does not exist by default. So, like Spring provides some extensions, you can and should write your own extensions for a new project. So here, I'm going to add an extension that will add this format method to local datetime. And here, I'm using a custom English date formatter to write a fully formatted English date. So with that, I'm really adding a new method to local datetime. And if I go to see my HTML controller, you can see that I'm using it. So concretely, that replaces all the util classes that you are using in Java in a much more nice way. So I'm going to update this template with a more complete form. I'm going to add an article. That mustache. Okay. So, okay, article, we should be fine. And I'm going to add some bins. That will be an example. So here, since I'm going to add some bins, I add a body to the application. Okay. So I'm doing that. I'm adding some configuration of the mustache compiler. And I am going to add some data initializer, okay, with the command line runner to put some data by default it is a in-memory database, like Josh said, and so I want to have some data. So I run my application. I hope I have not forgotten anything. Okay. And if I go to the browser, okay, so you can see that I have a wonderful blog engine, and I click on the link, and I can see various articles, so that's working. We are two last parts. I'm going to create a REST web service, okay? So, HTTP API, I'm going to add that. So that's a regular Spring MVC controller with the @REST controller annotation. I'm still doing implicit auto-wiring of the constructor parameters. When you have a single line in your function, you can use this short notation for one-liner functions. And the key point to understand is that we are still in a static typing world. I mean, even if I don't specify the return type of find all, it will automatically take the return type of find all by order by added at desk. So it will concretely have this type, these return types, even if I don't specify it. Obviously, I can also specify it if I want, but here I will stick to this minimal version. You can see that I'm using more functional construct than in Java with the when, but basically that's just shorter version of the controller. I'm going to write some tests for that. So I'm creating HTTP API tests. Okay. I'm going to write this kind of test. So here I'm using the @WebMVC annotation to only create the web layer. I'm going to mock my repositories with mockbin. It is not yet supported at constructor parameter level, but I have created an issue to get that supported, and I hope we will be able to make it. I'm going to add another dependency, which is the Mockito support for Kotlin. That's not mandatory, but that provides some useful stuff like whenever, because when is a Kotlin reserved keyword, okay? So Mockito Kotlin support provide a whenever alias to avoid this kind of issue. And if I run my test, my mock test, it should check the result of my HTTP API with JSON path and things like that. Okay, that works. The last part of my presentation is to add configuration, because you are likely going to have this kind of thing. So I'm creating block properties, okay, which has that will be block.title, for example. I'm going to enable it at application level, so I'm enable configuration properties with block properties class, and I could directly add block.title here, but you can see I have no autocomplete, no validation. There is something missing. Something missing is enabling the annotation processor to be able to do that. So there is various manual steps. I hope that will work by default, but currently you have to do this manual step. So you have to enable annotation processing in ID. You have to go to the build in order to add the apply plugin Kotlin capt. So capt is the Kotlin plugin for annotation processing. Okay. Which I have almost finished.
No, take your time.
Kotlin capt. Okay. I have also to run manually capt because sadly it is not yet properly integrated. Oh, sometimes I lose my keyboard, so I have to rerun. No, that's a bug on Linux. So, okay, that shit happens.
If that happens, I just touch the keyboard.
Yeah, but
it's hard to screen. I mean, it steals focus.
Okay, so okay. So here I'm running capt manually to generate the metadata based on my custom annotation. Okay, and now blog dot. It does not work. Okay, because I guess. No, that's okay. Yeah, I have. Ah, yeah, good point. Okay, so in addition to add that, I need to add the dependency. So I need to add the Spring Boot configuration processor with the capt configuration, import the change, rerun my. We are going to make it.
Awesome.
Okay. And now if I go there, you can see that I have autocomplete validation. I'm writing Toto, and last step, I'm going to use that here. So I'm adding private val conf block properties. Okay, I'm injecting that, and here I'm using conf.title. Okay. And I will just choke. I will just run my application. Ooh. Maybe it's already running. Okay. Okay, Toto, it's taken in account. That's all.
Wow.
Your turn.
Amazing.
Do you want to?
I'll switch. Yeah. So what did we do? What did we establish? First of all, you were able to build an application that looks sort of like a Java application, except much less code.
Yeah.
You were able to use APIs that look very similar to what we have in Java, but you were able to do so in a much more concise way. For example, with the model map, you could just use operator overloading.
Yeah.
You have these nice DSLs here. Didn't spend a lot of time wasting time on semicolons and things like this. And it's just in every way it looks very nice.
Yeah.
What would be the big takeaway here is I think Kotlin is a great choice for building applications that you would have built yesterday, right?
Yeah.
And you can run this on Java. This doesn't require Java 11 to run. You can run this on Java 8 or 7 even.
You are reusing all your Java knowledge with a more efficient language, shorter code. I mean, you have seen the data classes are very, very concise, so you have less code to maintain, so less bug and easier maintenance of your code. But as you are going to show, we can build very different application. Here we have reused the regular annotation-based programming model. So that's a perfectly valid use case for Kotlin. I really think that Spring Boot 2 and Kotlin are ready for production right now. That's a low-risk approach. But you can also use the latest fancy stuff with the functional programming model, and I guess that's what you are going to show. Yeah.
Do I need this Wi-Fi? I've already connected to the Wi-Fi.
Okay.
All right,
Wi-Fi.
nobody torrent anything.
It's not yet on the screen.
Is it not?
Not yet.
That's bizarre. It's Linux, so it just works usually.
Yeah, plug and play.
Well, I did my part.
Maybe go to the display to check it's mirroring.
Should
Okay,
be.
mirror. We are mirroring.
Come on.
And
All right, good stuff.
Yeah.
Hasn't failed me once in a year and a half. What is this?
Ooh.
Application authentication.
wireless.
I'm running.
Cancel, and I'm going to plug that.
Keep changes. All right. So we are. Is that faster? Did I just lose? Let's see. Info. No. Let's see if that's makes it worse or better. There we go. Good. All right. So we have this beautiful application. We looked at Kotlin as a way to sort of make building existing applications easier. But where I really enjoy using Kotlin is in the possibilities for sort of new applications. These new applications that can take advantage of some of these amazing DSLs that are expressible or possible with Kotlin. Kotlin lets you build these kinds of applications with less cognitive overhead, right? You get to write applications just like you would before, but you have less to think about. And that's, I think, the real value here is not just taking existing code and cleaning it up, which is nice, right? It's certainly nice, but it's this whole new world of ideas that you can think about because you have this new domain. And while Java 8 has functional support, it has Lambda support, that support isn't married to anything else, right? Whereas Kotlin is more of a sort of a holistic language, and if you take advantage of all those features, you can create some really, really stunning experiences that you just can't duplicate in, for example, Java. So we're going to use Kotlin here. We're going to start at my second favorite place on the internet. Anybody here know start.spring.io? I'm just curious. Okay, so enough of you. By the way, just curious, how many of you are using Kotlin already? That's always something I always wonder about. What does that look like? Is that a half? I don't know. Yeah, less than half. A little bit? A quarter?
Slightly.
Yeah. Okay, well, not enough. Either way, so welcome to Kotlin. We're going to generate this project. I'm going to use Maven because I'm a terrible person, but either way, you have lots of options. You could use Gradle. Is there going to be Gradle Kotlin support anytime soon?
At some point, yes, I think.
So Gradle, it supports Kotlin as well. That's perhaps an option. We're going to use Kotlin. We're going to go ahead and build a new application today. And we're just going to call this demo because why not? And what we're going to do is we're going to use several of the new APIs here. We're going to use the reactive web support in Spring Framework 5. and Spring Boot 2.0. We're going to use the Spring Cloud Gateway project, right? Spring Cloud Gateway. And we need some sort of persistence option. And again, we have a lot of different options here, but we want to do something that will allow us to talk to a persistent database. And again, I could switch to the full version where I so inclined. I could switch to the full version. And I'm given a veritable ocean of checkboxes, things that if I wanted to, I could add to my application. But since we're doing reactive, first things first, these are not for us, right? These synchronous and blocking choices, while you could use them, they're not a particularly great fit for what we're trying to do. So let's skip that instead and focus on these NoSQL options. We have Redis and reactive Redis. We have MongoDB and reactive MongoDB. We have all these different options here. We should choose from among these different options those that are starting with reactive. So reactive Couchbase or Cassandra, both fine choices, but I don't have them installed on my local machine. So instead, we're going to have to content ourselves with reactive Redis, perhaps, and reactive MongoDB, because when you want to lose your data, and you want to lose it reactively, there is nothing better than reactive MongoDB. So we'll go ahead and add that to the application. Again, a couple things to keep in mind here. We're using Java 8. There are only two choices here, right? These drop-down menus imply choice where there is no choice. The first drop-down menu gives you the choice of JVM that you should use today to support. Oh. All right. These give you the choice of drop-down of JVM languages that you can use to build these applications. We're using Spring Framework 5, which requires a Java 8 or better baseline, although Kotlin, strictly speaking, does not. We could use Java 9, but that isn't supported anymore, right? They have a 6-month release cadence such that it's already no longer supported. You have to use Java 10 or better. So, and then as soon as you move to Java 10, as soon as Java 11 comes out in September or October, as soon as that comes out, you have to switch. So for now, it's better to stay at a long-term release like 8 and wait until 11. So we're going to use that. And then, of course, we have the choice of packaging. People are often confused by this. I've been trying to help with this particular question for a long time. Which choice of packaging do you use? And there's a lot of good choices here. If you're, for some reason, for whatever reason, you are confused, I'll give you my level-headed best attempt at explaining this. If by some terrible tragedy of time space, some fluke of physics, you should find yourself somehow transported to the distant, distant, distant past, then choose .war. But if you're here with us in 2018, in the future, then choose .jar. This is a big part of our overarching and guiding personal philosophy of make jar, not war. Now, I'm going to open this up. I've got a zip file here. I'm just going to open this up in my IDE, and we're going to demonstrate some of these nice APIs here. We're going to open up an IDE, and we're going to build a reactive application. I'm sure you've seen a number of good talks already at this wonderful show. By the way, thanks for coming. What an amazing turnout, huh? Good stuff. Good job, Sergi and team, first of all. So we're going to build an application here, and we're going to, same thing as before. We're going to build an application that writes data to the database, Wi-Fi permitting. All right, demo. So here's our application. You will have noticed, right, that the build itself is already aware of Kotlin. You can already see that Kotlin has been pre-configured for us here, right? So Sébastien here has been at the head of all the efforts in the Spring team to sort of make Kotlin a great choice for everybody in the Spring framework, in the initializer, and so on. So really, all this is just because he put in the extra time. So this just works. We don't have to worry about that. What we get to do now is we can use the application to write some code. And what I want to do is I want to write an application that, can you see that font? Is that too small? Let's make that a little larger. I mean, it's like the size of a human being on the screen, but it feels small relative to the rest of the screen. So 2.2, here we are. Very good. All right, so there we go. So we're going to build an application that writes data to the database. We're going to use a class. We're going to write data to the database of type reservation, as I always like to do. And we're going to do this Java style first, right? So imagine how this would look. I'm going to say val ID string question mark equals null, right? So here I'm saying I want to have a field that's an ID, that's a string, that's nullable. So Kotlin cares about nullability. And I'm going to have another field called reservation name. Now, in this case, this is also nullable. In this case, I want this to be, I need getters and setters and toString and equals and all that stuff. So rather than do all that myself, I'm going to use a nice feature in Kotlin that lets me express things using a data class, right? Which we saw in the last session there. So there we go, last example there. So there's our data class that's going to create getters, setters, equals, all that kind of stuff. And I want to be able to write instances of this to the database. So I'll create a reservation repository that's going to extend the reactive Mongo repository just to have something in there. So we're going to say reservation of string. And we don't need that, of course. And then now I'm going to write some data to the database. So I'm going to create a bean, a data writer. And this is going to be a bean that implements the application runner callback interface in Spring. And this callback interface is just an interface that when Spring perceives it on the application, it's going to call and give us a chance to do any kind of initialization, any kind of stuff that we want to do to initialize the application. And to make this work, I'm going to inject the application writer, and I'm going to write some data to the database. I'm going to say val names equals flux.just. This is a reactive publisher, and we're just going to use some names here. Sébastien. Let's see. We got some Spring team members I can think of. Violetta, Madura, and Spencer. There we are. There's 4 names, okay? So now I'm going to write each one of those names to the database. I'm going to map over it. And again, I could do this as Java. I could say map like this, and then declare a name, and then turn it into a reservation like that, and then pass in null for the ID, and then pass in the name. And I could do that. That's certainly possible, but that's Java style. So in Kotlin, if you have a parameter that's a lambda, if it's the only parameter or if it's the last parameter, it can be outside of the parentheses like this, right? I don't need the parentheses. In this case, it's the only parameter, so I don't need the parentheses at all. Also, did you notice that there's no new? That's kind of nice, right? And I have this lambda, and the lambda defines an implicit parameter. Well, the implicit parameter, the name is obvious. The compiler can say, okay, I know you've got one parameter, so I'll just give it an implicit name called it. And also, I've got this data class, and this data class has addressable fields. So I can say reservation name equals it, right? That cleans it up a lot. I don't have to worry about all that. So now, reservations equals, and now what I want to do is I want to visit each one of those, reservations.map, and turn that into data that's been saved into the database. So reservation repository.save it. Now, when I use this callback, what I get is actually a publisher of publisher. So I need to unpack that intermediate thing. And there we are. So I'm going to say saved. Now that's going to, if I run this code, nothing will happen. I have to actually subscribe like this and then print out the results. But what I really want to do is delete everything first, right? So I'll say reservation repository.delete all. Then I want to get the data from the publisher, the combined data from the publisher here, and then write that to the database. And then I want to get the data from the repository and then print it out and subscribe to the whole thing. All right, so there we are. So there's the records, there's all the data that comes back from the database. Let's see if that works. What will that do if we run this code? Well, it'll write the data to the application, to the database, and then it'll reflect that output on the console. So let's go ahead and run this here. I'll take some tea. Alrighty. There we are, look at that. It worked. Of course it worked. It was a demo. What were you expecting? This is not really why we're here. As always, I care about this, but there's other things that I care about more. For example, ASCII artwork. And so this is my never-ending quest. And if you're here, Jan, you should know about this. This ASCII artwork is amazing. As you know, on the Spring team, we have people that are PhDs, people that are doctors, people that work in their previous lives in nuclear physics. And for this reason, I want to take a brief moment to talk about this amazing ASCII artwork and to talk about what I consider to be a very serious and glaring deficiency in the IntelliJ JetBrains product. For while I'm a fan, I consider this to be particularly short-sighted. Do you see that checkbox? That checkbox says hide banner. What the hell? Why is that even there? So I did what all people do in this scenario. I went on the internet and I cried loudly. And I was sent a message of hope from my friend, Jan Sebron. This is my friend, Jan Sebron. He's here somewhere. He sent me this message of hope. Software developer by passion at IntelliJ IDEA JetBrains. This is him. Right? And he sent me this great message, which I share with you here today now. Now, I only mention this because, he keeps saying it'll be in the next release, and this was 2016, so, I'm not feeling really loved. But whatever. So anyway, we have amazing ASCII artwork. We have data in the database. Now, let's talk about this application. We've got an application, and this is a top-level type. I've got a component that's sitting at the top of the application stack, and I want to use that data. But this whole thing is kind of wasteful. I want the side effect. I just want this, right? All this other stuff. I've got a top-level type. I've got a constructor. I've got an interface. I've just got a whole thing that nobody's going to use except for the framework. I want the side effect. I could create a bean, a Spring Framework bean like this. I could say fun runner and then inject the reservation repository there. So reservation repository equals, and create a expression. In Kotlin, you can create a bean, a function, a member function that has a return value that's just one expression. And that would work certainly, but this is still, I have to do all this just to have that. What I really want to do is I'm going to tell the framework, here, just run this. And so I can use now a new style of dependency injection in Spring Framework 5 called functional bean registration. So here I'm going to say add initializers, and I'm going to create a beans element, a beans attribute. This API is available in Java as the application context initializer callback, but really my favorite way to do it, and the only way that feels clean, is to use it like so. So I'm going to say application runner, and then this repository, I want to look up a reference to it. So I'm going to ask the framework, I'm going to say, give me a reference to that repository, like so. I'll say, find a reference to it for me, like that. And I'll use that here. So that's actually, I'm registering a bean. And the reason that this is kind of nice is because, well, this is a function invocation, right? I can actually do weird things that you wouldn't otherwise normally do, not so easily anyway, right? I can say if math random is greater than 0.5, then register this bean. Or I could do a for loop or something like that, right? You can do all sorts of weird stuff that wouldn't be so easy to do in regular bean definitions in Java configuration, for example. So this is certainly one nicety that I like in Kotlin that you can't really do in Spring with Java. Okay, so this is the first thing. The next thing I want to do is I want to build a REST API. So we have an API, and I want to build a REST API. I could create a Spring MVC style controller, but I prefer to use the new functional reactive REST endpoints. And again, there's a Java API for this that involves router functions and all this kind of stuff, right? You can do all that, but instead we're going to use a nice DSL here that allows me to say get /reservations, all right? And here I'm just going to return a response that contains the data there. So I'm going to say I want to inject that reservation repository as before. And this ref API, by the way, is kind of interesting. Notice that there's no class literal. I'm not passing a type token. I'm not saying reservation class Java to make this work or anything like that. I don't have to. You see, thanks to Kotlin, we have what are called inline reified functions, or basically macros. When the compiler sees this ref, it's going to copy and paste the source code from the implementation into the call site. And the result is that the compiler can insert a type token. It can capture, sort of like this. It's sort of doing this kind of thing behind the scenes. And the result is that we can write this ref code as though we had a pointer to that type literal right there in the implementation. So the benefit is that we get kind of quasi-pseudo reified generics, and the benefit is that we don't have to specify the type parameter there, all right? Also, similar here, we have an extension function. This body function, usually in Java, it takes a second parameter of type class. This is the type token. We don't need to do that here because of reified generics and that extension function in Kotlin. So let's go ahead and run this again and see what we get. Now, I have this application. It's up and running. I'm a big fan. Localhost 8080/reservations. There we are. There's our data. Now, this is a simple REST endpoint. I want to also be able to proxy data from another service. And so there's a great use case here for a gateway, an API gateway. And we can use here a new project that is reactive first called Spring Cloud Gateway. And Spring Cloud Gateway is a reactive first API that you can use to build applications that handle API gateway kind of concerns. There's a nice DSL for this as well. So I'm going to say create a route, and I'm going to match an incoming predicate. I'm going to say whenever somebody goes to proxy, then I want to send them to a URL. I'm going to say let's send them to spring.io :80/guides. All right. So there we are. Okay. Now I'm going to go ahead and restart the application. And you can do all sorts of interesting things with this API gateway. You could insert filters, for example. You can insert a filter to do rate limiting or anything like that. If you have a fragile downstream service that's not going to be able to scale very well, maybe it's written in WebSphere, for example, and it can handle 5 requests per year, then you can use these filters to protect that fragile service, right? So here we are. Here's the application, and it's up and running. And I'm going to go to proxy now. Oops, that's proi. That's not a word. Proxy, and there you go. You can see the output from that. Now, I'm a big fan of what we just did here, and you can see that there's a lot of nice APIs in Kotlin. And this application, mind you, keep in mind, this doesn't look very much like what you might be expecting from Spring, right? This is actually very different. And really, this whole thing right here, is silly. This is a demo, not real code. So that's my whole application. That's reactive data access code that can talk to a reactive database that have a REST endpoint and a proxy. And the DSL is very different from what you might expect from Spring. Also, notice the ubiquitousness of the parentheses. You see, thanks to functional reactive programming in Spring Framework 5 and Kotlin, we have brought the joys of parenthesis counting from Lisp to the JVM. So you're welcome for that. Now, we have this bean, we have this data there. Now, I like this application. It's a very simple sort of kind of Spring-based microservice. But I do want to stress that you can use Kotlin for all sorts of other interesting use cases. And if you're going to, if you're going to go to, for example, Serverless. Serverless is a great platform, a great idea. It gives you an opportunity to describe workloads that are asynchronous, that happen in the background, right? You want things that you can use that eventually get called when you need them to. They're not going to happen immediately. These should not be in the front end of your application. They should be in the back office domain of your application, right? So let's create a very simple function using Project Riff. Project Riff is a function as a service platform from Pivotal. It's open source. It's based on Kubernetes, but it runs on top of any Kubernetes distro, including Pivotal Kubernetes Service, PKS. So I'm going to create a very simple Spring Cloud function application here. And again, the goal here is to stress that you can use these very, very lightweight technologies like function as a service platforms and write very, very lightweight code using a lightweight language like Kotlin. Now, I'm going to run over just a little bit, and while I should feel sorry, I don't. So that's weird. So we're going to go ahead and create this application. And this application is going to be, we're going to use Spring Cloud Function. How many of you have used or seen Spring Cloud Function already? I think the good Dr. Sire already gave a talk on it, did he not? Yeah, you say that. But now, we're going to go ahead and add this application here. And we'll have to set up the dependencies for Spring Cloud Function. We're going to do this the old-fashioned way, the way that we used to do before we had start.spring.io, which is, after all, my favorite place on the internet. We're going to add these dependencies ourselves. Now, hopefully, these checkboxes will be on the initializer in time for Spring Cloud Finchley GA. I don't know. I'm just a hopeful person. So type POM. There we are. Okay. And now we're going to add Spring Cloud Function Web. So Spring Cloud Function. Okay. Spring Cloud Starter function web. Get rid of that. Don't need to qualify the version. Don't need functions. All right. So there's our application. It's got the code. Now we're going to write a very simple function. Again, this is the nice thing about using this. Oh, I used a Java. Son of a gun. No. It's terrible. Okay, we're going to try this again. Kotlin, uppercase. I did it wrong. We should really reset the default to be just Kotlin. Yeah. Like,
not accepted yet.
Like, we can do better. Okay, let me get rid of all that extra code. Goodbye. Demo. UAO, uppercase. Oh, that was so embarrassing. Java. I looked at the code and I'm like, oh, that's so much more code than I wanted to write. What happened? Oh, Java. So embarrassing. Does it ever happen to you where, like, you're going to be productive and then you use Java? Oops. It's going to be a beautiful day. All right, so I've got this application. Same thing, this time faster. Okay, so here we are. Dependency management section. Dependencies. Dependency. Spring Cloud Function dependencies. Scope. Import. Type. POM. All right, and dependency. Starter. Function. Web. All right, now we have this application, very nice little Kotlin application, and all I'm going to do is I'm going to register a function here. I can do this using Java configuration or the functional reactive functional bean definition. So I'm going to say fun uppercase equals, I'm going to create a Java 8 function, not Kotlin, that's important, Java util function of publisher of string as the input and the publisher of string as the output. And again, all I'm trying to do is to take the data that comes in, map each word into uppercase, and then return that. So there's my whole thing. I'm going to go to the command line here, cd uppercase, maven clean package. Okay. Oh, I should have done, minus skip test because YOLO. All right. So there we are. There's the application up and running. And I'm going to now deploy this to Riff. And I have Riff running on my local machine here, and I haven't deployed it. So I'm going to say Riff create Java. Minus A is the target handler. That's the artifact. The input name, the input Kafka topic is going to be called up. The name of the Kafka topic is going to be called, of the function is going to be called up. And the handler will be uppercase. That's the name of the bean. And the main class will be com example.uppercase application. And I do want you to appreciate that.
KT?
What? Oh, son of a.
Yeah.
I did it wrong.
Because that's a top-level function, and it's wrapped into.
So he makes a great point. So we're going to do this uppercase application KT, is that right? I can, and you taught me a great trick about this yesterday. I can copy and paste this reference here, to be sure. So I want to take a moment to just, so that we can appreciate what's happening here. The incantation, riff, create Java, blah, 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 there's more code here than there is in my actual function. So that's nice. It doesn't give me, oh, well, is that right? Okay.
Yeah.
So uppercase, blah, 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 main, go. Okay. Riff, list. There, it's up for 3 seconds. I'm going to publish a message on the input channel called, what do we call it? We called up. And the data is going to be hello, or no, hola, Spring IO. Okay, and I'm going to ask for a response. So this is going to post to my Riff gateway, my HTTP gateway running on my local node here. It's going to spin up the application and give me the result back. Okay, my friends, that was a very simple example. Hopefully you got something out of it. The goal here is to demonstrate how nice this language makes existing Spring workloads and to demonstrate that it makes an ideal choice for new Spring workloads.
Yeah, I think that's over. Just more stuff is coming about functional APIs, DSL, so I will talk more about that at Spring 1 later in the year, but thanks for your attention.
Gracias por venir. Thank you so much. I have some questions. Did you get something out of this? Okay. I have another question. Would you take a photo with us? Okay. Come on, buddy. Okay. We're going to count down to tres, okay? So, uno, dos, Spring. Oh, that's so good. Thank you.
Thanks.